We'll now relate the work to the energy change. We have our equation for work. Work equals force times the distance that it moves in a parallel direction to the force. So if the object is not moving at all, then d parallel will be 0. No work is done. The work is 0. The energy of the system stays the same. If the object moves opposite the direction of the force, for example, if the force is positive and the distance is negative, the displacement is negative, then the work is negative. The energy of the system is reduced. Again, the best example of that is if you're driving a car, you're moving, let's say, in the easterly direction, you put your brakes on. You are now going to accelerate in the westerly direction. You are still moving east, the force is west, you're doing negative work, and the energy of the system, your car, is decreasing, you're slowing down. And the last case, of course, if you're moving in the same direction, the work is positive. The energy of the system will increase. This is the case where you hit the accelerator pedal and you go faster, your force is in the same direction of the displacement, the energy increases. We have units for work and energy. Since work changes energy, they have the exact same units. Now work, over here, is measured in newtons, distance is measured in meters. So we can say the unit of work and energy is the Newton meter. It can also equal, by putting in the definition for Newton, it can be a kilogram meter squared per second squared. Now that's rather awkward to say every time you want to speak about energy. So in honor of James Joule, who made critical contributions about energy and how it relates to work, it has been renamed the Joule. So 1 joule equals 1 Newton meter, which also equals 1 kilogram meter squared per second squared, and is represented by the capital J. James Prescott Joule was instrumental in showing that different forms of energy can be changed into other forms, most notably mechanical to thermal energy. Work also done by James Watt with his efforts on the steam engine. Before Joule, it was commonly accepted that thermal energy is conserved. It always stays the same. It cannot be moved into a different type of energy. This was disproved by Joule because he took extremely accurate and precise measurements showing how thermal energy can move into mechanical energy. It's just another type of energy. The emphasis there is accurate and precise measurements, sort of the hallmarks of good physics. Now this was made possible by his experience as a brewer, which required very accurate measurements of temperature, time, and volume to create the right product. A very interesting example of cross-disciplinary work.